Alright people, so we know about vectors, we know about how they have an I and j component. A position vector is just a fancy way of saying that it's a vector drawn from the origin to a point. So it's a vector from the origin to a point. So if you look at this, oh gosh. If you look at this diagram over here, it's just OA is a position vector.
So
and OB is also a position vector. Okay. Now, this is very, very different to relative vectors, and that's basically the vector of one point to another point. So the vector that joins A to B in your diagram is the relative vector. Or B to A, depending on what you want. Alright, so position vectors always from the origin, relative vectors from one point to another point. We'll do 3 examples and then we'll dive into it. So points, example 1, points A and B have position vectors 2i plus 3j and 5i take j respectively. Find A, B. There's a nice little diagram there. So once again, we have to go from A to B, and we have to follow the vectors. So from A to B, like that, we have to go, let's see, we need to go A to O, and then O to B. So you need to go A to O, like so, plus O to B. So tip to tail. Now hold the phone because AO is actually negative OA. And OB is already a position vector. Well, that's OA there, and that's OB there. So I can just substitute my vectors for the i's and j's component. So negative 2i plus 3j plus 5i minus j. Add up the i's and j's, easy money. 3i minus 4j. Alright, so just to show you how position vectors are used. Example 2 adds in a little bit of flavor in your bland oatmeal. At 1 p.m., a ship is located at location A, which is this point over here, and it gives you the position vector. Notice kilometers, so it's just a distance. And it's moving with a velocity of 5i minus j kilometers per hour. So position, velocity. If the ship continues at this velocity, what will be its position at 4 p.m.? So the first thing we have to do is that assume at 4 p.m. the ship is at B. Is at point B. Now, how many hours has it been? How do I turn this kilometers per hour into just kilometers, into a distance? Yep, so speed multiplied by time gives me distance. In other words, OB plus OB equals OA. So OB equals OA plus AB. Now OA is quite simple. OA is 2i plus 8j. But AB, well, let's see. We have a velocity, but we want distance. And it's going to be 3 hours away. So I'm going to have to multiply my velocity by 3. I'm going to stop there. Any questions on why I multiply by 3? All good? Easy money? Alright, so once again, expand the brackets, simplify it. 12 plus 15 is 17i. 8 minus 3 is 5j. So my position vector at 4 p.m. is 17i plus 5j. That kind of makes sense. It's all the way out here. Alright, so let's draw this line over here. Let's draw this diagram, sorry. Points A and B have 2 position vectors. And we have to find the point that divides AB by the ratio 1 to 2. So, a little bit messy there. Let's start with the diagram. Can you draw position vector A and B for me, please? Just roughly. It doesn't have to be to scale. Just a quick sketch on exactly where they'll be. So, if you look at those numbers, A is only 1i plus 7j, and B is 10i plus 4j. So very, very roughly, where would I and j be? I would say maybe A would be here somewhere. Yes? Do you concur? And then B would be, well, obviously here somewhere. Let's fill in. So position vector A is over there. That's A. What's wrong, guys? You got a question for me? No. Okay. Absolutely fine. Except for your ankle, of course. Yes. Foot. Yes. Now it says that find the position vector of the point that divides AB internally in the ratio 1 to 2. So let's draw AB. That's AB, and we're going to divide it in the ratio 1 to 2. So we're going to divide by 3, and AP is 1, PB is 2. So roughly around there, and we'll call that P, like so. All good, Brendan? So now we're trying to find this vector here. So visually, we're trying to find this bad boy over there. Well, let's see. How do I get? So what I want is I want OP, because I want the position vector from O to P. Right, I want OP. How do I get there? Well, let's see. The easiest way, well, I can do this two ways. I can go this way and then that way, or I can go up and then across. So I can start with AP. Sorry. Oh gosh. I can go OA plus AP. Now, before I move on, anybody confused at why I wrote those two things down? Easy money? Okay. Now AP, well, it's a ratio of another vector. AP is actually a third of AB. So what I can do is I can write down OA there. And I can say AP is actually a third of AB. That's true because it divides the ratio of 1 to 2. So AP is a third of AB. And then, hold the phone. I've got vector A and vector B there, and I got OA and AB. Can I just substitute my vectors in? Well, let's see what happens. OA is vector A plus a third AB. Let's see. From A to B. Sorry, guys. From A to B is actually negative A plus B. So negative A plus B. So if I follow negative A, I'm going this way, and then positive B, I'm going that way, which gives me A to AB. And all I do is substitute. Well, I can simplify this to 2/3 A plus a third B. I don't have to, but it just makes it easier for me. And then, oh look, A is over there, B is over there. Last and final step, substitute my I's and J's in. Let's see what we have over here. We got 2/3 I plus 7J plus a third 10I plus 4J. So you would have to multiply that in there. So basically a third, 2/3 I plus a third of 10. That gives me 4I. 2/3 of 7 plus a third of 4 gives me 6J. And that is OP. Or the position vector of point P. Questions? Queries? Debates? Arguments? Brendan? If you wish, Brendan, you may watch the funny video. That's okay. I'm going to stop the recording now. So.